Hello, here in this video we're going to look at week 28. And the first bit here is simplifying radicals. So this is all about finding the perfect squares. So what that means is we want to re-express this 75 as two numbers being multiplied together, and we need one of them to be a perfect square. Now in this one, I see a 25 times 3. Alright, now what that allows me to do, rewriting it like this, is we know the square root of 25. We know the square root of the square root of 25 is a 5. So what that allows us to do is put this 5 on the outside. And we've got a square root of 3. That's it. Alright, and you know you finish these problems when the only number left over is your something that's not a perfect square, nor can it be broken down. Now sometimes the number it'll give you here already is a perfect square. Right? If I asked you what the square root of that 16 is, right, you're going to tell me that that is that 4 here. Right? So sometimes it already is a perfect square. Now with this, like if we're looking here at number 5, some people might see this as maybe a 4 times a 10. Alright, 4 times a, sorry, that's not right. Right again. Some people might see this as the 4 times the 20. Alright, because they see that that 4 is the perfect square. And that's fine, but let me show us what's going to happen here. When I take this square root out, there's going to be the 2, that when we get the square root of the 4, then we still have the square root of 5 left over. So I'm not all the way finished simplifying here because I can continue to break down this square root of 20. Alright, I could rewrite this as 2 times the square root of 4 times 5. And then we see another square root of 4, which would come out, we give us another 2. So whenever this happens, we have two numbers multiplying together on the outside. They multiply, so 2 times 2 is 4. That's a 5 left over. Right? So this is what happens if you don't use the largest perfect square. Now, what you could have done on this one is realize that 80 is really times a 5. So that would be using the largest perfect square. That way, when I square root our 16, a 4 would come out, and we would have a 5 left over. And you can see the answers are the same, but using the largest perfect square saved us some stuff. I didn't have to do that process twice. We only had to find one perfect square in there. Alright, so for week 28, page 2, it's all about using the quadratic formula. Right, and that is for us that negative b plus or minus the square root of. We have our b squared minus 4ac all over 2a. Right, so that's the formula we're going to be using. We need to identify what our a, b, and c values are. And also remember, the quadratic formula has to be equal to 0. All right, you'll see that the majority of these are equal to 0. One's going to have a square root answer, and show all work. Now, there's no way you're doing the quadratic formula in your head. You have to practice using it here and finding your two x's. Let's go down here to number 7. Now, the first thing you need to recognize is that we are not equal to 0 here. And on this one, we're going to need to fix that by subtracting a 4 from both sides. All right, this will cross off. Now I have 4b plus an 8b. And then 7 minus the 4, that's going to give us a 6. Now we are equal to 0. All right, make sure this is the equation you're using for your a, b, and c, and not this one, because it wasn't equal to 0. Let's set up. I have a negative b plus or minus our b squared minus our 4 times our a, our c is a 3, all over here a 2a. Right, and I just got this from, this is my a value, this is my b value, and this is my c value. Right, and then we just simplify this out, right? So the negative goes to the 8. We've got a plus or minus. I'll figure out what all of this is underneath. The number that we're going to get here is going to go inside this square root. Right, so 8 squared, that's a 64. Let's see, so then we have a negative 4 times a 4. It's going to give us a negative 16. A negative 16 times a 3 is going to take us to a negative 48. Right, so then what we really have to think about is what is that 64 minus that 48? And when we do that, all over an 8. Because this 2 times 4 gives me an 8 there. Okay? Now we're going to split off into our two different cases. Right, our plus case and our minus case. Now, I know what the square root of 16 is. So we've got our negative 8 plus square root. Alright, and so this one's going to be the exact same. Minus 4. And then we just finish solving this. Right, well, negative 8 plus a 4 divided by 8. This tells me that one of my x's, this is going to simplify here, negative 1/2. Alright, for this other one, we have a negative 8 minus a 4 to get a negative 12. Negative 12 divided by the 8, we can simplify that to a negative, or negative 3 over 2. Right? And those would be our two answers for that equation right there. Alright, so be on the lookout, make sure they're equal to 0, make sure one of them you find has a square root answer. Alright, so here we go. On week 28, page 3 and page 4, all follow the same instructions here. It says graph the following using the vertex, the x-intercepts, and if possible, the y-intercept. It may not fit on there. Alright, and I said you may complete the square, use the quadratic formula to find your x-intercepts, or factor. Right? Oh, it says that too. And factor. Whichever method that you want. But I'm going to come down here and I'm going to take a look at this equation right here. All right, so for our vertex, let's talk about that. We know that our vertex, so this is an important piece of this page, is our negative b divided by a 2a here. Now, something you may have noticed, this equation does have a greatest common factor in it, right? But we'll talk about how to address that kind of in a second here. So the vertex is always negative b over 2a. Our y-intercept is always 0, comma, and then our original c value. Right, so our y-intercept for this one is going to be 0, comma, negative 6. And I can go ahead and put that on the graph. I know that whenever I finish graphing this, it will cross over at a negative 6. Now, so keep in mind that the y-intercept is the original c value, because you could factor out a and have an x squared, a 2 minus a 3. And this minus 3 is not the y-intercept. It's got to be the original one right there. Okay? But to find the vertex, when you use the negative b over 2a, you can use either one of these equations. They're both going to give you the same thing. Alright? So if I do that for this one, I'll use the second equation. I d value of 2, so I need a 2 all over top of that 2a. Alright? So this will tell me that the x-coordinate for my vertex is at a negative 2 over 2, which is a negative 1. Right? So here for my vertex, I've got that negative 1. Now remember, to find this y-coordinate, we need to plug this x-coordinate into either one of these equations. And I'll choose this second one just because it's a little bit smaller. So what we're doing here is I'm taking all original equations. Everywhere I have an x, I'm plugging in a negative 1. Okay? Alright, now negative 1 squared. Let's turn it into a positive 1. Right, then 2 times the negative 1 gives me a negative 6. And we have a minus 3. And don't forget, we're all still multiplied by this 2 right there. Alright? So 1 minus 2 minus 3. I can put these together to get a negative 5. Negative 5 and a positive 1 is a negative 4. Alright? So it looks like the y-coordinate for my vertex is going to be a negative 8. Right? I can go ahead and put that on. So if we go to negative 1, then we go all the way down here to negative 8, we also see where my vertex is. Now we can do that there. Okay? Alright, so let's talk about how to find our x-intercepts. Like I said, you may factor. You may complete the square. You may use the quadratic formula. I'm going to take a look at this equation, and I'm going to factor it. Right, so here's me finding my x-intercepts. All right, I'm going to factor this equation and solve it. Okay, so I could break this down into the following factors. I know it's going to be an x and an x out front. Get our x squared. Now I need to have that. It looks like a positive 3 and a negative 1. Right, so this is what a factor is, because 3 times the negative 1 gives me negative 3. 3 plus the negative 1 gives me the 2. Now to solve for our x-intercept, I take those two and I set them both up equal to a 0 and solve it out. We'll get that one of ours is negative 3, and the other one is equal to a positive 1. All right? So that tells me my x-intercept is negative 3 and a 1, comma 0. Now I can get those put on. So here's our negative 3, 0. Here's our 1, 0. So now you can really see this parabola start to come in. And one thing that it says up there is to use symmetry. All right, it doesn't say that, but we know that there is symmetry down through the middle of this vertex. What that tells me is at this point, I can flip that over there to complete that parabola. And then there we have it. All right, good. So it's a decent amount of work, but it gets a lot of stuff that we've talked about in here. The vertex, the y-intercept, the x-intercept. Solving for that from factoring, quadratic formulas, some of those different methods. All right. Now for these, one thing to keep in mind for both of these, see they have a negative out in the front, right? You're going to want to fix that. Right? We already talked about how to factor when that happens. So I would go through and rewrite both of these, except just with the negative back out. All right. So I would use this equation. Right. Scrap that one, right? Take out whenever there's a negative out front, pull it out, and then work with this as your equation, right? That way we more or less get to ignore this, except for the occasion when we're going back in to find like the other part of our vertex, things like that. But do remember, we do need this as our original y-intercept, right? And this one won't fit on the page, and that's all right, okay? So for here, before I mess with anything, make sure you get this as your original y-intercept. And then you may recognize that you can have a greatest common factor of a negative 2 there. So I'll leave it up to you to figure out what's left over in here. All right? And that's it. So if you're more comfortable using the quadratic formula, you can do that. If you're more comfortable factoring, you can do that, or completing the square even. Just make sure you find all of these different components, and you are getting a nice parabola.